Exponential function derivatives. The derivative of e to the x is e to the x itself. This is the only function that is its own derivative, making it incredibly special in mathematics. For a general base a to the x, the derivative is a to the x times natural log of a. With chain rule, derivative of e to the f of x is e to the f of x times f prime of x. On the graph, at any point on e to the x, the slope of the tangent equals the y value itself. At x equals 1, the value is e, and the slope is also e. Example. Differentiate y equals e to the sin x plus 2 to the x. For e to the sin x, apply chain rule, e to the sin x times derivative of sin x, which is cosine x. For 2 to the x, use the a to the x formula, 2 to the x times natural log of 2. Final answer, e to the sin x times cosine x, plus 2 to the x times ln 2. The chain rule for composite functions. If y equals f of g of x, then dy by dx equals f prime of g of x times g prime of x. In Leibniz notation, dy by dx equals dy by do times do by dx. Think of it as a pipeline. X goes into the inner function g, producing u equals g of x. Then u goes into the outer function f, producing y equals f of u. The chain rule says, multiply the rates of change at each stage. The mnemonic, differentiate the outside function, keep the inside unchanged, then multiply by the derivative of the inside. This is the most important differentiation rule for g. Example. Differentiate y equals sine cubed of 5x squared plus 3. This has 3 layers of composition. Outer layer, something cubed, derivative is 3 times something squared. Middle layer, sine of something, derivative is cosine of that something. Inner layer, 5x squared plus 3, derivative is 10x. By chain rule, multiply all 3 derivatives together, 3 sine squared of 5x squared plus 3 times cosine of 5x squared plus 3 times 10x, simplify to get 30x sine squared of 5x squared plus 3 times cosine of 5x squared plus 3. Remember, each nested layer adds one more multiplication in the chain.